In this video, I'm going to tackle the beast, the infamous subnetting. This topic causes a lot of headache for everyone who's just been starting out in networking. But when you get the hang of it, it becomes intuitive. By the end of this video, you will be a subnetting sensei, the master, figuring out how the f we do subnetting to why we need to do subnetting in the first place. Before we dive into this, let's begin, shall we? Now, first thing first, let's take an IP address of 192.168.1.1 with a subnet max of /24. With these just two information, we can find out the network address, broadcast address, and the number of hosts a network can have. For those who don't know these terms, network address is the first IP of any network. It is used as an identifier for the entire network rather than the IP for the individual devices. In easy words, it is a label to identify the network. Similarly, broadcast address is the last IP of any network. And as the name suggests, whenever a device has to send some packet to all the devices, essentially broadcasting it everywhere, the broadcast address is used as a destination address. And the remaining in-between addresses are assigned to the devices in the network. These are called as usable host addresses. But the question is, how do computers find these addresses? Let's take both IP and subnet in their binary form. The computer finds the network address by performing bit-by-bit AND operation between the IP and the subnet. And the resulting value is the network address. Similarly, if you invert the subnet marks and perform the bitwise OR operation, we're going to get a broadcast address. And this is how computer finds these addresses. Now just to wrap up, this IP address is also a part of 192.168.1.0 network. And in a network with /24 subnet marks, we get a total of 256 addresses. But the first IP is used as an identifier and the last IP is for broadcasting. So we are only left with 254 addresses for the host. Take a mental note of how /24 subnet gives us 256 addresses in total. But we only have 254 to use. We'll come to this information later on in this video. Now let's bring our focus back on subnetting. You can skip the chapters if you know what you're doing with your life. Otherwise, sit back and enjoy the show. To better understand subnetting, we have to first break down the IP address. An IP is just a decimal representation of a binary number. And our IP actually looks like this to the computer, just a series of ones and zeros. And the subnet mask of /24 is just a cool way of writing 255.255.255.0. And it is also a decimal representation of a binary sequence. /24 is just a CIDR way of writing a subnet mask. And it just tells there are 24 turned on bits or the ones in the subnet mask. And subnet mask is what helps us to separate the IP into two parts, network portion and the host portion. Yes, you heard it right, there are two parts to the IP. See, the individual character in the binary is called a bit, and a bit can either be on or off, represented by 1 or 0. In this IP with subnet mask of /24, the on bits or the ones represent the network portion, and the remaining off bits or the zeros represent the host portion. Now look at the decimal format. The 255 is what you get when you have all the bits turned on in the binary. But the real question is, why do we have the network and host portion in the first place?
Good question.
If you are watching this video on the Wi-Fi, check your Wi-Fi setting. You will see an IP address there. For the most part, it would look like this. Now, if you compare this IP to any other devices on a network, such as your laptop, then you will see an IP something like this. Look at this. The first three value is your network, and the last number is for your devices that are in your network. Here, all of your devices are in the same network, but their host portion are different, thus giving each of them a unique IP address. If it still doesn't make any sense, rewatch this portion again after completing this video. I promise it will make more sense. So where were we? Now at this point, you should be able to identify the network and the host portion. Wait, let me test you. In this example, which part is network portion and which is host? Answer in 3, 2, 1, go! The turned on bits is network portion and remaining is the host. Did you guess it? Another example. Yeah, you are a genius, man. Now the final one. Wait a minute, something's wrong?
Dumbass.
This one is hard because so far we've been using the full octets, also known as classful subnetting. But now it's time. Enter the classless subnetting. In our previous examples, we use a full octet for our subnet marks. But we don't really have to use the full octet, and the real power of subnetting actually lies in this. The ability to take a single network and break down into multiple smaller networks. It's really the heart behind the subnetting. Oh yeah, subnetting. Now before we dive into juicy subnetting, you gotta learn the theory first. Let's have a look at why the subnet of /24 gives us 256 addresses to begin with. It all goes back to binary. A bit is just a switch that can be either on or off. A single bit gives us two possible outcomes, either 0 or 1. With 2 bits, we can get up to 4 combinations. The number of combinations increases exponentially, and this formula will give us the total number of combinations we can get using n number of bits. Using the formula and increasing our number of bits, we get to the octet chart. Remember, these are just combinations for the corresponding number of bits. And when using a subnet mask of /24, we are left with 8 bits for our host. It can go from all zeros to all ones, and when it's all 1, the total sum is 255. That's why in a network, our IP address goes from 0 to 255, giving us a total of 256 addresses. But in a subnet of /25, an extra bit is taken for the network portion, and we are only left with 7 bits for the host. And with 7 bit, our network can go up to 128 hosts, that is when all the bits are turned on. We no longer have an additional bit for the host. So after this point, we jump to the next network. So with subnetting, you broke a single long network into 2 smaller chunks, just by reducing the number of hosts the network can have. But one thing still might confuse you. Why /25 gives us 128 here? Alright, it looks confusing in the decimal format, but looking at the octet chart, we see what is going on. Only the first bit is on, that's why we are only getting 128 value. Now, let's take another example with /26 subnet. Here we have 6 bits for the host. You could directly say, with 6 bits, our network can have up to 64 IPs, and break our large network into group of 64. You can see how the network is smaller when we increase the value of subnet marks. /26 broke our normal network into 4 smaller chunks. And don't forget, each smaller chunk is a network in itself, with their own network and broadcast addresses. Now think about it. When we go down, the network size decreases. What if we go up now? Well, in that case, we'll have an additional bit for the host portion, thus a larger range for our host, which increases our network size. And this is called as supernetting. Supernetting is exactly opposite of subnetting. But the question is why? Why even go with this mindfuck idea? The simple answer is to use the IP efficiently. If we need a network where there are going to be around 1000 users, the only way to make our host range a little bigger is to have a smaller subnet mask. Similarly, if we just have 6 users, we can use a subnet of /29 to get 8 IPs. From those, assign 6 addresses to each of these hosts, which leaves no room for other intruder in this network. In this way, subnetting also helps with better security. That is all, folks. We tried to cover the general idea of subnetting, but there is more we need to discuss on this topic. But we'll see that in the future. So, learn something new? Drop a like. And if you don't subscribe to us, you'll be missing out on a lot of great explainers. I'll see you in the next session.